Hello and welcome to this short tutorial about Docker. We'll cover the most important aspects such as what are containers, what are images, what are Docker files, and we'll cover of course the why. Why do you need Docker? So let's get started. Without Docker, how does the world look like? Well, let's say I have my machine and it has an OS, for example Linux or Mac, and I've installed some programs, for example npm version 5.3 or Python 2.7. And as a developer, of course, I have my apps. I have app 1, which is based on npm version 2, and let's say app 2 based on npm version 5. But you can see now I have a problem. On my machine I have installed npm version 5, but app 1 requires npm version 2. So we need some kind of isolation. We need to be able to bundle together our dependencies with our application. And Docker is exactly what provides us this isolation. It provides us with Docker containers. And Docker containers are a boxed environment which bundles together some dependencies, which some application code, and where you can run everything in an isolated environment. And you can see here, for example, container 1 runs npm version 2.4 and container 2 has installed npm version 5. So this isolated environment is really what gives us an edge with Docker. So this is one of the key features of containers in general, this isolation. What's furthermore a benefit of Docker containers or containers in general in comparison to VMs is that they are really lightweight. So maybe you have at sometimes installed, let's say, Parallels on your Mac or Linux on some other system with a VM, and that was a really heavy thing. It had many gigabytes and it required quite a lot of memory from your system, so you wouldn't be as crazy to run like 10 VMs on one system. And Docker containers are much more lightweight, which is one of the whys. So since they're so much more lightweight, you can actually run many containers on one machine. They don't require as many system resources as full-blown VMs do. And the other benefit is the same as with VMs. It works everywhere, exactly because of this isolation. And this is cool because let's say you have a Red Hat server and you want to migrate to Ubuntu, then it's no issue with Docker. Or let's say you have Azure cloud servers and you want to migrate to Amazon cloud, no problem with Docker. And there are more benefits like security and other things. But for me and for this tutorial series, really this isolation and spinning up your app with exactly what it needs is the main key feature. And also that they are lightweight, Docker containers. So how can you actually set up a Docker container? Well, we need to specify somehow what should get installed in a Docker container. And we do this with a file called Dockerfile. And this Dockerfile is really named Dockerfile. It doesn't have any extension, so you just create a new file called Dockerfile. And this file specifies the setup instructions for this isolated environment for the container. Now, this is a simple Docker file that installs Node, and you can see it's looking pretty similar to like when you just install Node on your machine. The only difference is that in front of every line you write run. So, but basically it's just like what you would write in your terminal, prefixed with run. There are more commands that you can give to Docker, to a Docker file, but this is just to get you started. And often you build a Docker file from a so-called base image. We'll get to what is an image in a minute, but this kind of shortens this installation of Node here. I just say from Node 8. It gets Node 8 from somewhere because someone already has written a Dockerfile that somewhat looks like this, and we can actually install Node, and then it's just a bit less boilerplate code. Because often when you run Docker containers, you write like microservices and you don't want to install too much, and you just need Node, for example, and it has been pre-built. Now let's try and get such a Docker container to run. To do so, I've set up a new server, an Ubuntu server, and here Docker is not yet installed. Now I'm heading over to the docs. They provide the useful resources, docs.docker.com, and here are the installation instructions. So we're just quickly running them. And if you follow through with the installation process, in the end you should be able to run this hello world, hello from Docker. As you can see, I have switched into super user mode. That's because if you don't, initially you'll get permission errors with Docker. How you can set it up in a better way we'll cover in another video. Here we'll just use super user mode. Now let's try to spin up a container from this Dockerfile we've previously written. So now I have 5 lines. I have where to get Node from, and then I'm just printing actually the version of Node and the version of npm. And spinning up such a container is actually a 2-step process. Step 1 is to make a build from the Dockerfile. So the Dockerfile has some installation instructions and we need to build this thing. So how can we do this? It's going to go with the docker build command. And the docker build command takes one argument. It's the directory where the Dockerfile is residing, and this is my current directory, so I just specify a dot here. And it also has optional arguments, for example -t, to give your build a name. So I call it step 1 here. And then I can also specify the no cache option here. That's just to get everything from scratch, because I have actually already built it, so it's going to get it from cache, but not if I specify no cache. And you can see here it has built everything, and it prints my Node version and it prints my npm version. So I have made a successful build. Now the next step would be to run the container from this build, and this is again with the telling command docker run. So I can simply run docker1 step 1. Oh, but nothing happens. And that's right, because we didn't tell our Docker container to do anything. We just told it install this stuff, but now what? What should it run? What should it do? It doesn't know what to do. So the next step is we're gonna have to tell Docker what to do when it runs the container. To do something as a last argument here, I can provide a command. And for example, my command could be hello world. Okay, great, that worked. Now we have installed Node for a reason. We want to actually execute Node programs. For example, this hello world program here, which we usually could execute with Node hello world.js, but I haven't even installed Node here, so nothing's happening. But why don't we use our Docker build to run this hello world Node app? So similar to the echo hello command, I could write docker run step 1, which has our build dependencies, which are Node and npm, hello world.js, or at least so would I expect. Oh, I forgot the node commands. So, but this doesn't work. So why does it not work? Node tells me it cannot find the hello world.js. And for this, we need to step back a bit and have a look at the conceptual overview again. So you remember how we initially drew our containers inside our host? Well, we said there's a lot of isolation going on, so this doesn't actually know too much about the host. So we could just as well draw it in a different manner. So the container doesn't actually know anything about my host. And we can verify this by just typing ls in the host and see, okay, I have a Dockerfile here and a hello world.js file. But in the container, when I run the same ls command, we have seen we can just put in commands to the Docker container. Then I see it puts out a whole new list of directories that is not here on my host. Also, if I try to go to this directory, home Ubuntu source docker toot, which is this one, I see this directory doesn't even exist. So there's really a lot of isolation going on. But now we need to be able to break this isolation in order to get our hello world.js file inside of the Docker container such that we can actually run it. And one way to break this isolation is with the v argument, which stands for volume. And with the v argument, you can specify a directory on the host and the directory in the Docker container, and then this directory on the host gets mapped into the Docker container, such that if we were to run this command again, the directory would actually be found. So let's try this. Okay, so how can we get this directory inside of our Docker container? Well, as we said, it's going to go with the Docker -v for volumes command. And on the from side, I'm going to put exactly the directory I'm currently in. You can't just put a dot, you need to put the full path there. And inside of the Docker container, we want it to map to the exact same Docker container again. Then the build we're going to run is step 1. And last but not least, the command we're going to execute was ls, and we want to check what's inside this directory. And now we printed those files, and now they are inside of our Docker container. And to compare this again, if we wouldn't map this directory, it says, okay, it's not there. So by mapping it, we made it accessible inside of the Docker. Now, since this was a bit a lengthy command, there's a trick to shorten it. Probably you're aware of the pwd command, the print working directory command, which prints where you're currently residing. And instead of hard coding the directory here, which wouldn't work maybe on someone else's computer, you can just write pwd here. And here you can do the same. And let's try it again. One too many. Like this. And you see it has the same effect as if we hard coded all of the values here. That way, if you switch this and were to put this command into some kind of shell script or something, then you wouldn't actually break the script. So now that we know how to map volumes, we should finally be able to run our node program. So with the pwd, we have mapped our volumes, and now I could run the step 1 with Node. But remember, if I print ls here, I'll still be in the root. So now I would need to run Node from also this directory. So from, let's say, pwd hello world, right? And it prints hello world. But it's still not that nice that I have to put pwd here in front of my hello world, because usually I would prefer to write it just like this. I would prefer to be inside of that directory when I run the node command. So how can I achieve this? This works with the -w flag, and W stands for working directory. It's very similar to the cd command in the shell. So I'm cding into pwd, so into this directory here, into the Docker container, and now I don't have to put this pwd in front of the hello world. Well, and that's it. Now I have my first working Node program through a Docker container. Nice, isn't it? So we have seen that getting a running container is a two-step process. First, we have to make a build, and we had a Dockerfile, and where our Dockerfile resided, so in the current directory, for example, we ran docker build, and we gave our build a name, and that's how we made a build. And as a second part, we could run the container with the docker run command and pass it the name of the build and give it some optional arguments like the volume, and provide it with a command to execute. Now I had to really force myself to not call this build image throughout this video tutorial, because in the Docker community, or defined by Docker, this build is called an image. So if you call this command, the build that gets generated is called an image. So what are images? They're kind of like pre-built Docker files. So it's what gets generated if you run this docker build command. And once it's generated, it's a template to spin up new containers. So you see here, since this was a two-step process, in the first step we made the image. This took a while, maybe like 5 minutes, maybe 10, doesn't matter. But once it's built, then starting up a new container is pretty fast. And this is why it's split into this two-step process, because usually you have the specifications of what you want to install Node and everything, and you want to run this only once. And once this is ran, you want to spin up containers pretty fast. And so the docker run command just has everything prepared in an image, and it can just spin up a new container in an instant. So this is a long build step, and this is a fast startup step with everything already prepared. And so again, the why, so the having prepared images and not having to install everything from scratch saves a lot of time. And also, if you have such a pre-built image, you could upload it to Docker Hub or some other source where images reside, and other people can just download it, and they don't need to know anything about your Dockerfile or anything, and they can spin up containers from this image. But it has a considerable file size, so if you build a lot of images, you will see that you have a lot of gigabytes used on your machine or wherever you have Docker installed to store those images, because basically, like, sometimes you have Node installations. Sometimes you even install Ubuntu into Docker, and all of those images accumulate and can lead to quite a bit of file size. To check what images you have on your machine, you can simply run docker images, and you'll see, okay, I have one here that's 676 megabytes, and I have a really small image here, and you see all the images on your machine here. I don't have many because I just have this tutorial on this machine, but you can have like a lot of images on your machine. So we've learned a lot of commands today. We've learned to build an image with the docker build image, then we had to tag it, give it the image name, we had to specify the directory, we learned how to run a container with the docker run command, we learned how to print which images we have, and there's a lot of commands we didn't cover today. And all of those commands are part of the Docker command line interface, which provides all of those functionality to you. And there's quite a learning curve. So at first, I mean, how are you going to remember that you have to put directory last and put a -t here, or that the optional arguments are in front of the image, and so on? And you'll get more fluent with the time in this, but you can also always check the Docker reference. So here's the command line interfaces on the docs.docker.com, and for example, this is the Docker run reference, and here you see the general form. You have Docker run, then the options, then the image name, and then you specify the command. It's the same as I have written here. And those optional arguments, for example, those options, they are like really a lot. For example, you can have a silent mode with -d, a detached mode. You can specify the ports. We didn't cover that today. You can, for example, we had only the volumes flag. Where's this? The volume, or the verbose version with --volume. So learning about this CLI of Docker is a lot of work, kind of, because you learn all of these different commands, you learn about ports, you learn about everything, and there's a learning curve, but you'll get better and more fluent with this over time. And you can always check the Docker docs to learn something that you don't know already. So that's it for today. I hope you've enjoyed the video. Don't forget to subscribe and have a nice day.